Today, we're going to be doing some more applications with linear systems. We're at section 3.6. This is our last section in Unit 3. Let's get started. We're going to have some more applications, and these are the new types we're going to do. We're going to do vans and buses. We're going to extend the last weeks by multiplying while we eliminate. So they'll be a little more complicated in the math part, not necessarily setting up the equations. In the last part, we're going to be doing some travel with current. We did travel with current last week, but now we're going to add distance equals rate times time to that. Let's get started. All right, let's do these together. So go ahead and get your assignment sheets out. This is from section 3.6. This is number 1. We're going to do this one together. I want you to notice at the top up here, the instructions say that we're going to set up two equations from a description. We're going to solve them and label them correctly. You're going to show all your work. Let's do these together. The vans and the buses, that's the new kind we're going to do. And the instructions for it say, set up two equations with the description, from the description, solve them, and label the answer correctly. Show all your work. Here's the problem. Let's read it together and then we'll do it. The senior class at High School A and High School B plan a separate trip to a county fair. The senior class at High School A rented and filled 8 vans and 8 buses with 512 students. High School B rented and filled 7 vans and 2 buses with 193 students. Every bus had the same number of students in it as did the buses. How many students can a van carry, and how many students can a bus carry? The key to this is to figure out what is our variables. Are the variables for the High School A and High School B, or are the variables for the buses and the vans? The way I figure this out is I look at the questions at the very end. The questions at the end say, how many students can a van carry, and how many students can a bus carry? And that tells me what my variables should be. So that tells me that I need to have V for vans and B for buses, and that's the number of people on those buses. So then I need to have 2 different equations. One of the equations is for High School A, and I look right here, and it says that High School A rented 8 vans and 8 buses with 512 students. So here's my equation. I'll have 8 vans plus 8 buses with the 512 students. Then I have an equation for School B. And School B here has 7 vans and 2 buses with 193 people. I had some students in class asking me, well, don't the buses and vans all have the same number? So wouldn't we need we don't really need 2 variables, because it says here that every van had the same number of students, and same with the buses. What that means is that the buses and the vans, they don't have the same number of students, but all the vans for both schools have the same number of students that can ride them in them, and all the buses have the same number of students that can ride them, but that doesn't mean that the buses and the vans have the same. So you do need your 2 variables. Now at this point, we cannot add them because we don't have the 2 coefficients that are the opposite and the same number but the opposite sign. So we're going to have to multiply by one of them, and I'm going to multiply this one over here by -4 so that they will so that my b's will cancel right there. So I'm going to move this one over, and I'm going to say 8v plus 8b equals 512. And I'm going to multiply the 4 to everything on that side. So I'll have 28v negative minus 8b equals negative 772. Now these will cancel. I'm running out of room here, so we're going to have to make some room. All right, so I'm going to put these together right here, and that'll be negative 20v. And when I subtract those, that will be negative 260. Divide by the negative 20. V will equal positive 13. So my vans are 13. Remember, I'm not finished because I need to have vans and buses. So I'm going to plug them into one of these equations over here. I think the bottom one, that 7v plus 2b equals 193, looks like the best one. You don't have to put it in there. So when I put it in there, I'll have 7 times the 13 plus 2b equals 193. When you do all the math on that one, we bring that over, and then we divide by the 2, we get b equaling 51. Now, we're not finished because we need to write this out. We can't just have those two letters equaling. We need to say what it means because this is a word problem. So we have V, which is vans, with 13 students. And we have buses, or the bus can hold 51 students. All right, we're done. Let's move to another one. Now we're going to do some school fundraisers. Let's read the problem together. Ryan and May are selling flower bulbs for a fundraiser. Students can buy packages of tulip bulbs and packages of crocus bulbs. Ryan sold 8 packages of tulip bulbs and 4 packages of crocus bulbs for a total of $80. May sold 9 packages of tulip bulbs and 11 packages of crocus bulbs for a total of $155. What is the cost each of 1 package of tulip bulbs and 1 package of crocus bulbs? So, we need to figure out what our variable is. Our variable is for the tulips and the crocus because that's what the question asks. We have Ryan and May, and those are going to be we have a Ryan equation and a May equation, but our variables are the bulbs and the tulip bulbs and the crocus bulbs. All right, so for our equation for Ryan, which starts right here, I'm going to make a T for tulips, and I'm going to make a C for crocus. So this says that Ryan sold 8 packages of tulips and 4 packages of crocus for a total of $80. So here we go. 8 packages of tulips and 4 packages of crocus for $80. Now, I used a capital T there because I didn't want to use a lowercase. It looks a lot like a plus. Just need to be careful when you have that. The next equation we have is May. May sold 9 packages of tulips, 11 packages of crocus for $155. So that was 11T plus 11. I'm sorry, that was 9T plus 11C, and that's $155. That was May's equation. So this time we don't have anything that would cancel out very nicely. We're going to have to multiply 2 equations this time. We're going to have to multiply, if we want the T's to cancel, we're going to have to multiply the top by a 9 and the bottom by an 8. One of them needs to be negative, or if we want the c's to cancel, we'll need to multiply the 11 up here and the 4 down there and have one of them be negative. It just depends on what you want to do, okay? I think I want to do this one. So I'm going to multiply everything by 11 on that one and everything by a negative 4 on that one. Let's scoot over here and make it happen. So we're going to have 88t plus 44c, and the 80 times 11 is 880. Let's multiply this to everything also. We'll have negative 36t. We'll have negative 44c. And that will equal 155 times 4, which is negative 620. These do cancel out. And this over here becomes 88 minus 36 is 252t equals 0 and 6, 260 positive. We're going to divide by 52 and we'll get a t equaling. Let's move that out of the way. When we divide that 52 there, we're going to get a 5. Then we're going to plug it back in. I chose to plug it back into that 8t plus 4c equals 80. And then when you do all the math, you get c equals 10. Now make sure you label it. Now we're going to do some more current. This time we're going to have distance equals rate times time in it. In the past, you had only finding the rate in your problems. Now we're going to combine that current with distance, rate, and time, and your problems will have all three of those in it. Let's read number 5. A boat traveled 48 miles each way downstream and back. The trip downstream took 3 hours. The trip back took 6 hours. What is the speed of the boat in still water, and what is the speed of the boat in the current? So we're going to have, I like to draw. So we're going to go downstream, and we're going to go upstream. And I like to do my times now with those. We have a time that it took us to go downstream was 3 hours. And the time to go upstream was double that, 6 hours. Now our rates is something that's not really mentioned in here, but since we did this last week, we have experience with this. Going downstream, the current is going to help us because the current is going with us, going downstream. So the rate that we'll be going would be the boat's rate plus the current. The rate going back up will be the boat's minus the current because the current will be hindering us and keeping us back. Now that I've written all of this, we have one more thing to write and then we can write our equation. We have a total distance of 48 miles because they went down 48 miles and then back 48 miles. So each of the distances is 48 miles. So let's take our drawing that we have here and everything we need to do this whole thing nicely. We're now going to give ourselves two equations. We're going to do an equation for the up, and it goes like this. Distance equals rate times time. But I'm going to put the distance on the other side. So I'll have like my rate and time on one side and my distance on the other. I actually will have my time listed first, but since multiplication is commutative, it really doesn't matter. So I'm going to take this time and rate, and I'm going to put them together by multiplying them because rate and time make equal the distance. So I'm going to have 3 times b plus c equals that 48, because that's the distance that it went. Over here, I'm going to do the same thing. I'm going to take my rate, which is 6, and I'm going to have a b minus c, and that still equals 48. At this point, I want you to stop. Don't get ahead of me. Stay with me, because there is a trick to this to make your math easier. You could distribute this, and your numbers would grow. We're going to try to reduce these numbers. We're going to divide both sides by 3 and make total new equations. We're going to do the same one on here, and we're going to get something nice. We're going to get it so those c's will automatically cancel without doing much, okay? So the good thing about it is that 3 goes into 48 very nicely with no fraction, and 6 goes into 48 the same way. So we're coming over here. I'm going to do that downstream equation again. We're going to get b plus c, and we're going to divide that 48 and 3, and we're going to get 16. We're going to do the same thing. We're going to get this b minus c, because this will reduce. We'll have b minus c, and that's going to equal 48 divided by 6, which is 8. Everything's wonderful. We have those c's will cancel, leaving us with 2b here. And adding those together, we get 24. So b equals 12. We're not finished. We still have a current. We have many equations. We have 2 equations here we could plug it into, or 2 equations right here we could plug it into. I like these better. That b plus c equals 16, I would just put a 12 right there and plug it in. And we'll have 12 plus c equals 16. And we're going to subtract that 12 over, and we'll get c equals 4. We're not finished. We have to write what this means. It means that the boat traveled at 12 miles per hour, and the current traveled at 4 miles per hour. We just combined distance equals rate times time with the ones we did last week, where we put them in the place of the rate. But now we have to keep track of the time and distance with it. Let's move on to another one. This next one is going to be dealing with planes instead of boats. It's a very similar feel to it, but you're going to have to pay attention to which direction they're going is with the wind this time. So a plane traveled 1,392 miles each way to Tahiti and back. The trip there was with the wind. That's a key note, so you know which one adds this time. It took 12 hours. The trip back was into the wind, so we'll subtract on that one, because it's going to go against the wind. The trip back took 24 hours. What is the speed of the plane in still air, and what is the speed of the wind? So we're going to have 2 equations. We're going to go there and back, there and back, realizing that the wind is with them on the way there. We have time on both of them. Time there took 12 hours, and time on the way back took 24. My rate here, since the wind is going with us when we're going there, we're going to have the plane plus the wind. But on the way back, we're going to have the plane minus the wind. Now we can write our equations. Remembering that the distance both ways was 1392. Let's give ourselves a little more room here. Top one There's our first equation going there. We have distance equals rate times time. Remember, I just used the distance at the other end. It doesn't really matter. We still have our rate and time. And we put them kind of at first so the distributed property works good. So we're going to have our rate and time. That's these two multiplied together. So we'll have 12 P plus W, the plane plus the wind, is 1392. We're going to come and do the same thing for this one. 24 P minus W again equals 1392. We're going to do our trick again. We're going to divide both sides by 12 up here. And this one we're going to divide by 24. Let's get going. The nice thing about this is it makes it smaller when we do this. So we're going to have P plus W equals 1392 divided by 12, 116. When we do the bottom one here, we're going to have P minus W equals 1392 divided by 24. That gives us 58. These will cancel, and we'll have 2P equals, add those together, 58 plus 116 is 174, dividing by 2, P is 87. We're not finished. We have to plug that 87 back in. I'd like to suggest that we put it in the top one. So we have P, which is 87, plus W equals 116. Subtract it to the other side, and we'll get W equals, and W will equal 87. So we have the plane, and the wind is going to give us 20. I wrote that wrong. It was 29 right there. We already had 27. Pretty sure I said it. That was 29. And 29, and these are both miles per hour. All right. This is what we did in this video. We're still solving the two equations by substitution or elimination. These ones we did all by elimination, but we have some more types to solve, and we also have some that are just an extension of last week's where we have to multiply extra. I hope this has been helpful. Goodbye.